So here's our second example. And once again, we're going to ask which is the independent and dependent variable. So we have number of sick days and age. Now, would you say that sick days depends on age, or does age depend on the number of sick days? And once again, you'll see that the sick days, if you think about it, really depends on a person's age. So age is your independent, and sick days is your dependent variable. Once again, let's create the scatter plot. So I'm going to take this data and I'm going to put it in Excel again. So here's our data set. I'm going to take this and move it over so that our independent variable is first. Control or right click, cut, Control V, and then I'm going to select my data, insert, scatter plot, and there's our scatter plot. I'm going to add the elements. So in this case, that was age. And let's put units there, years. And on the vertical axis, that was number of sick days. Now you can see then, we'll add a number for the, say, age versus sick days for the title. There we go. And I'm going to move my chart. Let's say age versus sick days. And it creates its own its own chart in its own page. Now looking at this, you can see that the trend tends to be that it's going down to the right. So we should expect our R value to be negative. Once again, in terms of putting the trend line, if we right click on the data, we add the trend line. So there's the line of best fit. And over here, we're going to also include the equation and the R squared value. Okay, once again, you can make this larger. Home, let's make that a little bigger so we can see it. Let's make it nice and big there, and we'll make it bold. There we go. So there's our equation and our R squared. Now, with that said, let's go back to our data sheet and let's go through this and put our data in and see if we get the exact same value. So we want to put our data in. There it is. And once again, second data, second clear. And we're going to put these values in: X first, Y second. So 18, enter, scroll down, 16, enter, scroll down. 26, enter, scroll down. 12, enter, scroll down, and so on and so forth. And once again, I'm going to check the data, make sure it's all correct. And it looks good. So next, it's asking, determine the correlation coefficient. It rounded to 4 decimal places. So go second, stat, and scroll down until we get our R value. And there it is. So this is the value we're going to use, and then You can see it's negative, which is great, which is what we expected. And it is close to 1, so it's a strong negative correlation. So we have a strong negative correlation. And what does that really mean? As age increases, the number of sick days decreases. Right? That's what that stands for. Next, it asks, determine the linear regression equation rounded to 4 decimal places, and explain what the values represent. All right, so once again, we go to our calculator, and we scroll back up, and there are 2 values, A and B. And remember that B is your slope, and A is your y-intercept. So according to this, we have y is equal to negative 0.320064,335x, and A is 20.54262163, and then we can round up 4 decimal places for each of these parts. And there we go. Oh, I realized that was 3 decimal places. 5426. Now the linear regression equation, or the regression equation on the chart, was 3 decimal places here and 4 decimal places here. So it looks very similar. Okay, it's just a rounding thing. But you see that we're actually bang on. So next, what we're going to do is we're going to predict the number of sick days when a person is 30 years old. All right, so once again, what does that mean? We're going to substitute x is equal to 30 into our equation. And once again, I'll use the unrounded value. Times 30 plus 20.54262163. And when we do the math, we get the following. And when we substitute the values in, we get the following. And depending on how I ask you to round, suppose I said 1 decimal places, that's going to be 10.9 approximately, if that's 1 decimal place. Okay, and that's the number of sick days. All right, now using our calculator, once again, let's go to our calculator. If we have our data in there, we'll go second stat, scroll down until we get to x prime, and we're going to put in 30, hit enter, scroll down, and hit compute. And sure enough, there's the same value. Now, there is a rounding error here, or difference in error, in rounding, okay? But you can see that to the 1 decimal place, you get the same value. All right, so the test situation, I do expect all you have to do is use the calculator to find your predicted value when you plug in your x value. So once again, let's take a look at the chart and say, does this actually work out on our chart? So if we go to this scatter plot and we look at x equal to 30 and we work our way across, you'll see that, so 30 years of age, slightly lower, so it's approaching 11, like it's almost at the midway part. So if we actually rounded the whole decimal or whole value, it would be 11 in this case, right? And it actually reflects that on the chart. I'm going to pause, and we'll do the next example in the next video.